Question number 14 is of what kind? Okay, question number 14 says, find the intrinsic equation of the catenary. Catenary given here is, what is the catenary? Catenary is y equal to a into cos hyperbolic x upon a. Okay, this is the catenary here. Y equal to a cos hyperbolic x upon a. Hence, show that a into rho, to show that a into rho, rho is radius of curvature. Rho is radius of curvature. We know that rho is radius of curvature, which is given by rho equal to ds upon d psi. This is the value of rho. Rho is ds upon d psi. Known as radius of curvature. Is a radius of curvature. Okay, rho. A rho equal to a into rho equal to a square plus s square. This we have to prove here. A square plus s square. Okay. Let us take it. This is the catenary we are given. Find the intrinsic equation of the catenary. This and hence show that a rho equal to a square plus s square. No problem. Let us solve it. First intrinsic equation we have to find out. So solution. Solution. This is the y equal to a cos hyperbolic. Therefore, differentiating first. This is first equation. Differentiating first with respect to x, we get d by dx equal to a into sine hyperbolic x upon a into 1 upon a. Differentiation, coefficient of x is 1 upon a, so we have to multiply by 1 upon a also. As a cancelled out. This is nothing but sine hyperbolic x upon a. Okay, therefore ds upon dx, let me take whole square, is equal to 1 plus d pi upon dx whole square. It will give us 1 plus, now this is d by dx. D by dx is sine square, sorry, sine hyperbolic square, I'm sorry, is sine hyperbolic square x upon a angle. It is nothing but cos hyperbolic square x upon a. 1 plus sine hyperbolic x upon a is cos hyperbolic square x upon a. Therefore, ds upon dx equal to ds upon dx. If I find out, it is nothing but cos hyperbolic x upon a. This is value of dx upon a. Now, if I just convert it into y, that can also be done. Okay, no problem. Let us now solve it. So, this is to be integrated. So, within this limit, dy upon dx is, sorry, ds upon dx is this value. Therefore, arcual length, or first let me find out what is psi here. Now, if I find out tan psi, we know tan psi equal to dy upon dx, which is dy upon dx we calculated from this. It was a sine hyperbolic x upon a only. This was the value of tan psi. So tan psi equal to sine hyperbolic x upon a. Okay. So tan psi, if I have to replace this value sine hyperbolic x upon a by tan psi, that can be done. So we have to prove it as y equal to this. Okay. The question is this one, d square by ds upon dx is this value. Now let's solve it. So tan psi equal to sine hyperbolic x upon a. Now if I square this, then in terms of y we can okay, find out, but no need of that. Tan psi, let me take this, because in terms of, okay, and if I find ds upon d psi. Okay, now let me convert this into, this is ds upon dx. ds upon dx is cos hyperbolic x upon c. Sorry, this is cos hyperbolic x upon c. This is sin hyperbolic x upon c. Now, if I have to find out ds upon dx, d psi, so s is what? First, let me find out s in terms of cos psi. Sorry, this psi here. Then you will find out the rho value, and from that rho value, you have to calculate a into rho equal to a square plus s square. Okay, no problem. So rho is, we know that this is ds upon d psi. First, s is what? So arcular length here. Question is, show that the intrinsic equation of the, sorry, 14th question, find the intrinsic equation of the catenary y equal to a into cos hyperbolic x upon a. Hence show that a into rho equal to a square plus s square. Okay, that is the point here. So in this case, if I just find out this value in this case, so what is that value is given to us 0 to, if I find dy upon dx whole power 1.2, and it is tan psi equal to sin hyperbolic x upon a, undoubtedly. Okay, and if I just find out dy upon dx, then dy upon dx is sin hyperbolic x upon a. This is cos hyperbolic that I have already calculated. This is cos hyperbolic x upon a. 0 to s equal to, therefore this ds upon dx is cos hyperbolic. Therefore s is equal to 0 to x. Okay, into, this is ds upon dx into dx. The ds upon dx we have already calculated. This is cos hyperbolic x upon a. Now let me write it here. So this gives us this value ds upon dx. So it is 0 to x, general value, arcular length from any general point. Okay, so dx is cos hyperbolic. It is cos hyperbolic x upon a into dx. Integrating this, integration of this gives us sin hyperbolic. It will be nothing but sin hyperbolic x upon a on 1 upon a. That means a will come in the numerator. 0 to s here, because cos hyperbolic inverse is sin hyperbolic inverse, sub sin hyperbolic x upon a upon 1 upon a. Coefficient of x is a will come in the numerator, so a into sin hyperbolic x upon a. But sin hyperbolic x upon a is, so this is nothing but a into sin hyperbolic x upon a. This is what? Because at x it is x only, the same value, but at 0 it is 0. So only this. This is value of s here. Now if I put sin hyperbolic x upon a, which is tan psi, let me put it as a into tan psi. Because sin hyperbolic x upon psi, this is second equation. Let me take this first one. Tan psi equal to this dy dx. Alright. And therefore s equal to this we have to prove. And tan psi we know dy upon dx, dy dx, from this we obtained sin hyperbolic x upon a. And here sin hyperbolic x upon a we have substituted as tan psi, so a tan psi, this is, so s equal to a tan psi. Now if I differentiate it with respect to psi, because psi has been obtained. Now let me find out what is ds upon d psi. Therefore ds upon d psi, differentiating this equation, let me take this third equation, differentiating third with respect to psi, with respect to psi angle. So we get, what do we get here? Here we get ds upon d psi equal to a into tan, sorry, this is tan psi. Tan psi differentiation is secant square psi. Secant square psi. Try to understand. But secant square psi, this is rho here, rho equal to a into secant square psi. Now if I find s equal to, it was a into sin hyperbolic psi. Okay, so that we have to write here. So it is secant square psi, ds upon d psi equal to, or rho equal to this. So your rho equal to a into secant square psi. For differentiation of this gives us. Now, yeah, if I have to Okay, find out what is second square psi then. Okay, in terms of tan square psi, because tan psi was sin hyperbolic x upon a. Okay, so S here is a into sin hyperbolic x upon a. Okay, and if I convert this second square psi in terms of that value, then it will be a into psi. Okay, so rho is a second square psi. This we have obtained. If I multiply this by a, so then it will be a rho into a square second square psi. Second square psi, if I replace by cot square psi, it will be 1 plus cot square psi. That cot square psi we can substitute because s equal to a cot psi. Alright, that can be done undoubtedly. So that, let me write here. So therefore, here we have obtained rho equal to therefore a into second square psi. Got the point? If I multiply this by or a into rho multiplying by a, it is a square into second square psi. Now if I put a square, let me take common, second square psi is 1 plus tan square psi, we know. But tan square psi is s square, because a into, okay, if I take a, 1a inside, it will be a square into a square tan square psi, that is s square, alright. It is nothing but, if we multiply now by a, which is a square plus a square into tan square psi. Got the point? A square into a square plus tan square psi, a square into tan square psi. But a square tan square psi is s. It is nothing but a square plus s square, because this s equal to a tan psi. A square tan square psi is s square. This is s square. Therefore, a into rho is obtained finally. A square, a into rho equal to a square plus s square. This we have to prove. To find the, okay, to prove that a into rho is equal to a square plus s square. Okay, so this is how the relationship has been obtained. Intrinsic equation was s equal to a tan psi. This was the intrinsic equation. S equal to a tan psi. This was the intrinsic equation because relationship between s and the psi angle. This was the value. But we obtained this multiplying by a into this, then this relationship is also obtained. This is also proved. Hence proved. So finally, this has been proved. What we have done, we multiplied by a into rho, because ds upon d psi is rho, that I have defined. Rho is ds upon d psi. First we calculate the value of s, which is this one, differentiated with respect to psi. Ds upon d psi we calculated. It was a into second square psi, simple. And this ds d psi is a rho, multiplying by a again. It is a rho into a square into second square psi. Second square psi is 1 plus tan square psi. So multiplying this by a square into a square tan square psi. But a tan psi is s. A tan psi is s. This is s square. A square plus s square equal to a into rho. This is proved. Okay, so question number 40, they have completed. Now let me take the last question, which is 15th one. So 15th question is of what kind? Let me check it. Now question 15 says, find the intrinsic equation of y equal to a log secant x upon a. Okay, this is also of the same type. Here y equal to a into log of secant of x upon a. Y into log secant of x upon a. This is the question here, I mean curve here. Y equal to a into log of secant a. Let me write here, closure. This is of secant x upon a. Angle is secant x upon a of log. So it is the curve here. Find the intrinsic equation of this curve, y equal to a into log secant x upon a. Let me take solution. Solution here. So differentiating first, this is first equation. Differentiating first with respect to x. So what do we get? We get d by dx equal to a upon secant x upon a. First log, just reverse it, 1 upon x, 1 upon secant x upon a. But secant x upon a is not x here, it is again differentiated. Secant x is differentiated as secant x upon a into tan x upon a into 1 upon a. Why 1 upon a? Because coefficient of x, which is 1 upon a. So again differentiated by function of a function method. Okay, it is 1 upon a. So this a and this a cancelled out. 1 secant x upon a cancelled out. It is nothing but tan x upon a. Got the point? So tan x upon a is the value of dy upon dx. Got the point? Now we know that what is tan psi. So tan psi equal to d by dx, which is nothing but tan of x upon a. It means psi angle is equal to x upon a from this equation. Psi equal to x upon a. So in place of x upon a, we will replace psi. Simple. Now let me find out what is the intrinsic equation here. So arc length and arc length of the given curve given is s equal to, let me take, because it is d by dx, so it is okay, d by dx. So let me integrate this 0 to x, within limit 0 to x only. So it is tan square, it is 1 plus, let me take the square root of this, it is 1 plus d by dx whole square, and this is d by dx. So it gives us 0 to x, it is under the square root 1 plus tan square x upon a. This is tan square x upon a, tan square x upon a, okay, into dx. So what does it give? Just let me change the marker. So it gives just finally, let me write here, okay, so tan x was d by dx. D by dx is equal to tan x upon a. This we calculated. Okay, now from here, s we are calculating. S equal to 0 to x. Now 1 plus tan square theta is secant square theta, secant square and square root. It will be only secant x upon a into dx. So let me integrate this. We know that this is integration of this log of secant x upon a plus tan x upon a. This is the value of this tan x upon a and this value. So alright, this is s equal to. Now if I have to replace this, now limits are 0 to x. Let me write here 0 to x. So it will be the same limits, because reason is if I put x here, same at 0 it will be 0, but it will be 1. Sec 0 is 1, so log 1 is 0. That will be 0. So only this value only is obtained with that value. Let me write here. Therefore s equal to, so here psi equal to this. So it will give us log of only secant x upon a plus tan of x upon a only. This is value of s. Now if I replace x upon a by psi angle, it will be nothing but log of secant of psi plus tan of psi angle. Simple. This is intrinsic equation finally. Hence the intrinsic equation. This is the intrinsic equation. And the intrinsic equation of the this. So this is the intrinsic equation. Why? Because relationship between s and psi angle. X upon a we calculated, it is tan psi equal to dy upon dx, but it comes out as tan x upon a. We say psi equal to x upon a. In place of x upon a angle, we have substituted psi here. So this is the relationship between S and psi angle. This is the intrinsic equation or required intrinsic equation. Hence answer. This is the answer here. Question number 15 we have finally done. Log of secant psi plus tan psi S equal to, this is the relationship between this equation. Okay. So find the intrinsic equation of the curve this. Okay, so simple, we took limits from 0 to x. Under the 0 to x limits, we just calculated this. Finally, we have obtained the intrinsic equation. So this is the topic of this series. I mean, this lecture series now over 90. This is 92 lecture series. But up to now, we have taken quadrature. Oh, sorry, this is rectification. Now, rectification topic is over. Okay, next we will take volumes and areas and everything. Okay, that is the next topic. That lecture series is very important. Please don't forget to see that. That is also very important one, because as far as the engineering students are concerned, for them volumes, finding out areas, finding out with the help of trigonometric functions or integration is very important one. Okay, so that is also important topic. I'll take that in the next lecture series. So see you then. Until next time. Okay, see you in the next lecture then. Okay, bye bye.